Okay guys, so today we started talking about the slopes of parallel lines. So we're going to use this foldable for a couple of days. You can see it's these two sheets, so you need to stack them so that parallel lines and perpendicular lines are right on top of each other. And you'll fold it down from there, and then it'll end up making this layered, tiered foldable, and like that. And then you can put a couple of staples at the top to hold it, and then tape it into your journal. So today, we started by talking about slope. We just did a review of slope. So first, we talked about how slopes can be positive, negative, zero, undefined. This is not new information. We just reviewed. So we reminded ourselves that positive slopes increase from left to right, which is something like this. We talked about negative slopes decrease from left to right. And then we talked about how horizontal lines have slopes of 0, and lines that are vertical have slopes that are undefined. So just a quick review of that. And then we came down here and we said, okay, so if we can use a slope formula, if we're given 2 points on a line, we can find the slope of the line using the slope formula, or we also remember that we could use stat edit in the calculator. So, for example, number 1, if I want to use the calculator to do that, well, I go to stat, the stat button right there, and I hit enter for edit. I'm going to put my x values in list 1, which is 3 and negative 2. And I'm going to put my y values in list 2, which is 1 and 1. Then I go back to stat, and I move over to calculate. And then I want to choose option number 4, line reg, linear regression. And then I go down to calculate. And it's telling me that my slope is the a value, because that would be the value in front of x. And so my slope for example 1 is 0. So we can do the same thing with example 2. I'm going to go to stat, edit. I'm going to put my x values in list 1, which is negative 4 and negative 4. And then my y values I'm going to put in list 2, 3, and 7. And then I go back to stat, go over to calculate, I choose option number 4, linear regression, I go down to calculate, and it's giving me this error. It says error domain. So when you use stat edit and you get something like that error for the domain, that's telling you that your slope is undefined. So the calculator will give you that error. Most of the time that's a clue. Okay, this is probably undefined. And then if you look here, kind of hard to see, but there are 2 points for us here. So if we're given a graph with 2 points and they're wanting us to find the slope of the line going through those 2 points, just point there, well, we can find the coordinates of these points. So the coordinates of these points are, I go over in the negative x direction, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the coordinate is negative 9, comma. And then I go down 1, 2, 3, so that's negative 3 in the y direction. And then this point over here, I go over 1, 2 in the positive x direction, and then up 1, 2, 3, 4, 5 in the positive y direction. So there's the coordinates of my point, so I can come back now. And I can go to stat again, go to edit, and I can put my x values, negative 9 and 2 in list 1. In list 2, I put my y values, negative 3 and 5. And I go back over to stat, calculate, choose option 4, and then arrow down to calculate and hit enter. And it's telling me that my slope, which is what I'm looking for, the a value, is 0.7272, and it keeps repeating, 7272. That's repeating. So that's when I can do second quit, second mode, and then I can type in 72, oops, .727, if I can type it in correctly, 7272. I can fill up my screen with that repeating value, then go to math, and then hit enter, enter. And it's telling me that my slope is actually 8/11. So it's converting that decimal to a fraction. So my slope for the line going through those 2 points on that graph is 8/11. Okay, so then after we finished this, we did a little discovery activity about parallel lines, and then we moved on. In our activity, we actually discovered that parallel lines have the same slope. So if I'm given an equation, such as these, and I want to be able to figure out if those lines are parallel, I don't have to graph them and look at them. I can just discover what the slopes are, and then I can decide from that if they're parallel, because parallel lines must have the exact same slope. And that should kind of make sense, because if I have two lines, that the definition of parallel is that they run side by side and they're never going to touch. Well, if the slope of one of them, here's one line for example, if this slope's not exactly the same, if the slope of another line has a different steepness, then eventually they're going to intersect, because lines keep going forever. So in order for them to never touch, never intersect, always be the same distance apart, they have to have the exact same slope, because otherwise one of them could be tilted in the slightest little amount, and because lines keep going forever, they're eventually going to touch. So for these examples here, if I want to figure out what the slope is, well, are these equations in y equals mx plus b form? That's the question. No, they're not. So I can rewrite them over here, and I can solve for y to figure out what is the slope of the line, of the equation, and to determine if these two lines have parallel slopes. So in order to solve this one for y, to put it in, because I want my lines to be in y equals mx plus b form, I need y all by itself. So I need to move this x term. So I can subtract 9x from both sides, and it's gone from that side. I'm left with negative 3y equals negative 81 and negative 9x are not like terms. I can't combine those. So I just need to write them down on the same side. So then in order to the last step to get y by itself, I need to divide everything by negative 3. So then I'm left with y equals negative 81 divided by negative 3 is positive 27. Negative 9 divided by negative 3 is positive 3x. So I can see from this one, my slope is 3. So that's going to be important. I need to look at that in just a minute. So then for my second equation, I have 12x minus 4y equals 60. So again, I'm going to draw a line. I'm trying to solve for y. I'm trying to get it in this form, y equals mx plus b, because then I can just look and see what's the number in front of x, and that would be my slope. So I need to subtract 12x from both sides, because I'm trying to get the y term isolated. So then I have negative 4y equals 60 minus 12x, because 60 and 12x are not like terms. I cannot combine those. And my last step to get y by itself is to divide everything by negative 4. So I'm left with y equals, now 60 divided by negative 4 is negative 15. And negative 12 divided by negative 4 is positive 3x. Again, I can look and see what's sitting in front of x. That's my slope. So my slope is 3. Now, are these slopes exactly the same? Yes. So these lines are parallel. Okay. So then I want to move on to example 2. Well, I'm looking at these examples and I notice that y is isolated on one side. So y is by itself. So these lines are in the form y equals mx plus b. So now all I have to do is look and see what's sitting in front of x. That will be my slope. So for the first one here, I see that my slope is the number in front of x, which is 10. For the second one here, I see that my slope is the number sitting in front of x, which is negative 10. Now, are 10 and negative 10 the exact same slopes? The answer is no. Just think about it. 10 is a positive slope, and negative 10 is a negative slope, so those lines would definitely intersect. There's no way those could be parallel. So they're not exactly the same. So, no. These lines are not parallel. Okay, so then let's look at another example down here on the bottom. It says, determine whether the lines are parallel. Graph each line to verify your answer. So we're going to look at this one right here. So again, because these are in y equals mx plus b form, then I can just look and see, okay, what is my slope? My slope for this line is negative 1/3. My slope for this line is negative 1/3. So yes, these are parallel lines. So it's just a graph them to verify. So I'm going to look at the first one. I need to start with the y-intercept. So my y-intercept for this line is equal to 16/3. That's about 5 1/3. So I know I go up on the y-axis, 1, 2, 3, 4, 5, and just a tiny bit more. And then I know my slope is negative 1/3, so I have to go down 1 to about 4 1/3, and then I'm going to run 1, 2, 3 from there. So right there, there's about the first line. Anytime you graph by hand, it's not going to be exact. Now look at the y-intercept for my second line, and I see that it's 7. So I go up to 6, 7, and then I have the same slope. So I go down 1, and I run 1, 2, 3. So there's my 2 points. If I connect those points, I can see those lines do indeed look parallel. Now, for example 4, it's very similar. You could just plot the points and connect the lines. And so it would be easier to graph on these. You could plot this point and then plot this point and then connect the dots to draw the lines. And then to figure out the slope, well, you should just use stat edit. And that'll give you the slope of this line A and line B, and you can determine if they're parallel or not.